solution of state equation for DC motor model. Consider the following state space representation of DC motor. Red vector x1 dot, x2 dot equal to system matrix 0, 1, minus 2, that is in controller canonical form, multiplied by state vector x1, x2 plus input coefficient matrix 0, 1 multiplied by input. This is state equation. Output equation y is equal to c, that is 1, 0, x, that is x1, x2. Initial condition for the system is x0 is basically a column vector. Elements are x1 0, x2 0, x1 0 is minus 1, x2 0 is 1. Find unit step response for t greater than equal to 0. That is, input ut is equal to 1 for t greater than equal to 0 and 0 otherwise, or in frequency domain us is equal to 1 divided by s. So there are two different methods. Method 1 is Laplace transformation approach. The general solution of state equation in Laplace domain is x is equal to si minus a inverse multiplied by initial condition. This is 0 input response plus si minus a inverse times b times us. This is 0 state response. So combination of 0 input response and 0 state response is total response of the system. Now output ys is equal to c times xs. So first we calculate Si minus A. Here A is 2 cross 2 matrix for our case. So Si minus A must be 2 cross 2. But S is scalar, so I will be the identity matrix, which is 1 0 0 1, diagonal matrix minus A 0 1 minus 2 minus 3. That is equal to S minus 1. Second row is 2 S plus 3. Now inverse of Si minus A, that is equal to S plus 3 plus 1 minus 2 S divided by S square plus 3S plus 2. So now we can use this Si minus A inverse and equation number 20A to solve the state. So using 21 and 20A, xs equal to S plus 3 1 minus 2 S multiplied by 1 1 plus S plus 3 1 minus 2 S multiplied by B, that is this section, 0 1 and US is 1 by S, and the whole section is divided by S square plus 3S plus 2, this term. So if we simplify inside the bracket, then this into this plus this into this. So this will give you minus S plus 2, and the second element this into this into this. So it will be S plus 2. For this section, this into 0, this, so it is 1, and the second element is 1 by S multiplied by 1 by S, and the whole thing is divided by S square plus 3S plus 2. So further simplification inside the bracket, minus S plus 2, not plus, minus 2 plus 1 by S is plus 2 plus 1, S square plus 3S plus 2, or minus S square minus 2S plus 1 by S, second element is S plus 3, divided by S square plus 3S plus 2. Now output ys is equal to c into xs. C is 1 0 and this one is xs. So x is s square minus 2s plus 1 by s. Second element is s plus 3 whole divided by s square 3s plus 2. So if we simplify, then we'll get s square minus 2s plus 1 by s into s plus 1 s plus 2. Now y is written as c1 by s plus c2 by s plus 1 plus c3 by s plus 2. Actually minus half by s plus minus 2 by s plus 1 plus half by s plus 2. So we have to use partial fraction to find the value of c1, c2, c3. Now, the time domain response yt is Laplace transformation of ys. That is Laplace transformation of minus half by s plus inverse Laplace of minus 2 by s plus 1 plus inverse Laplace of half s plus 2. So we have to take inverse Laplace of ys. So ys is equal to this. So yt equal to minus half minus 2 e to the power minus t from this term, and from this one plus half e to the power minus 2t for t greater than equal to 0. Now we will go to method 2. State transition matrix. State transition matrix. So we will find a state transition matrix to solve the state equation and output. So here we have Si minus A inverse, which is s plus 3, 1 minus 2 is divided by s square 3s plus 2. Another form is s plus 3 by s plus 1 s plus 2. The first element, second element is 1 by s plus 1 s plus 2. First element of row 2 is minus 2 divided by s plus 1 s plus 2. First element of second row is s by s plus 1 s plus 2. After applying partial fraction in each element, we get two by s plus 1 plus minus 1 by s plus 2. This is from the first element. From the second element of first row, After applying partial fraction, it is 1 by s plus 1 plus minus 1 by s plus 2. First element of row 2. If we apply partial fraction, then minus 2 divided by s plus 1 plus 2 by s plus 2. Second element of row 2, if we apply partial fraction, then minus 1 by s plus 1 plus 2 by s plus 2. So this is Si minus A inverse, another form of Si minus A inverse. The state transition matrix is e to the power at. E to the power at is equal to inverse Laplace of Si minus A inverse. So if we take inverse of each element of this matrix, then the first element of row 1 is 2 e to the power minus t minus e to the power minus 2t. Second element is e to the power minus t minus e to the power minus 2t. First element of row 2 minus 2 e to the power minus t plus e to the power minus 2t. Second element of row 2 minus e to the power minus t plus 2 e to the power minus 2t. So this is the state transition matrix for t greater than equal to 0. Now the general solution of state equation is xt is equal to x z ir, that is 0 input response, plus x z sr, that is 0 state response, where x z ir, 0 input response, is e to the power a times t minus t0 multiplied by x t0. T0 is the reference time, and the 0 state response x z sr is integration t0 to t e to the power a times t minus tau multiplied by b multiplied by u tau, that is input. The operator is t tau. And output yt is equal to c z ir t plus c times x z sr. So first we will solve for 0 input response. So e to the power a is available in equation number 20. This is e to the power 80. So in our case, t is equal to t0 is equal to 0. So using 22 and 24a x z I r t is equal to e to the power first the state transition matrix 2 e to the power minus t minus e to the power minus 2t second element is e to the power minus t minus 2 e to the power minus 2t. First element of row 2 is e to the power minus t plus 2 e to the power minus 2t, and the second element of row 2 is e to the power minus t with a negative sign plus 2 e to the power minus 2t. So this is the state transition matrix. Now initial condition is minus 1 1. So if we simplify, then we will get minus 2 e to the power minus t plus e to the power minus 2t plus this one into this, so e to the power minus t minus e to the power minus 2t. In the second row, plus 2 e to the power minus t minus 2 e to the power minus 2t minus e to the power minus t. That means this portion multiplied by this one plus e to the power minus 2t. So this cancellation, so we will get minus e to the power minus t to the power minus t. So this is x z I r. Now x z is r, that is equation number 24b. So x z is rt is equal to 0 to t, because t0 is 0, e to the power a times t minus tau b multiplied by u d tau. Integration 0 to t. So the first term is 2 e to the power minus t minus tau. Instead of t, the operator is t minus tau here. So minus e to the power minus t minus tau. Second element is e to the power minus t minus tau minus e to the power 2 t minus tau. First element of row 2, 2 e to the power minus t minus tau plus 2 e to the power minus 2 times t minus tau. Second element minus e to the power t minus tau, the negative sign, plus 2 e to the power minus t minus tau. So this is e to the power a t minus tau multiplied by b, which is 0 1, and u is 1 unit step response and the operator is d tau. So if we simplify, then we will get integration 0 to t to the power minus t minus tau minus e to the power minus 2 times t minus tau, and the second element is minus e to the power minus t minus tau plus 2 e to the power minus t minus tau multiplied by 2 times t minus tau d tau. Now assume t minus tau is equal to z. So d tau is equal to minus dz. Now change the limit from tau to z. When tau equal to 0, z equal to t, tau equal to t, z is equal to 0. So applying this, t to 0, e to the power minus z minus e to the power minus 2z. This is the first element. Second element is minus e to the power minus z plus 2 e to the power minus 2z multiplied by minus dz. Now changing the limit with this negative sign, 0 to t e to the power minus z minus e to the power minus 2z is the first element. Second element is minus e to the power z plus 2 e to the power minus 2z dz. After evaluating, to the power minus z with a negative sign plus half e to the power minus 2z e to the power minus z to the power minus e to the power minus 2z. Limits at 0 to t. By putting the upper limit, first element will be minus e to the power minus t plus half e to the power minus 2t. Second element is e to the power minus t minus e to the power minus 2t. After applying the lower limit, first one is for first element minus 1 plus half, because e to the power 0 is 0, and the second element is 1 minus 1. So that is equal to minus half minus e to the power minus t plus half e to the power minus 2t, and the second element is e to the power minus t minus e to the power minus 2t. This is x, z, s, r, zero state response. Now output yt c times x z ir plus c times x z sr. So here is x z sr and this is z higher. C is 0, 1, 0, and x z here is minus e to the power minus t, e to the power minus t. This is the second element, plus 1, 0 multiplied by minus half minus e to the power minus t plus half e to the power minus 2t. The second element is e to the power minus t minus e to the power minus 2t. So from here we will get e to the power minus t plus minus half minus e to the power minus t plus half e to the power minus 2t. So from this it will be minus half minus 2 e to the power minus t plus half e to the power 2t. This is yt for t greater than equal to 0. Now we can see that this result is same as this. So solution of state equation using two different approach, and they are giving the same result.